All right, so first of all, the three main base units, the base unit is just a unit of measurement that we will be using that are from the metric system in this class, are meter, and meters are a measurement of length. So if you want to measure the length of something, meter will be your base unit. I'm going to write base next to that. So base unit just means it's the main unit of measurement. Okay, for volume, we will use liters. And this is for a liquid volume, okay? Remember that solid volumes are often measured in cubic units. So often you'll see a cubic centimeter or a cubic meter. Okay, that is still a volume, but liter is the liquid measure you'll see. And then lastly, we have grams, which is a measure of mass. And just remember, mass is like weight, except without the gravity piece. Okay, so when you think mass, think of like the weight of an object. The abbreviation for these, we use a lowercase m for meter, a capital L for liter, and a lowercase g for gram. So when you see those units, those are what we're talking about. Now, to go along with a base unit, you can also have a prefix to tell you if you have a piece that's smaller than the base unit or something that's bigger than the base unit. Some common base unit or some common prefixes are like milli, centi, kilo. Okay, some of those are smaller, some of them are larger. You are only going to have to know about 3 of these prefixes, and we'll focus on those in just a moment. But something that sometimes confuses the students is how we use these base units in relation to those prefixes. So if I told you that 1 meter equals 100 centimeters, when I write that centimeter, the C is the prefix, okay, so that piece that tells you how many of them there are, and the M is the base unit. So here we have that 1 base unit is equal to 100 centis of that base unit. If we were talking about the base unit liter, it would look like this. 1 base unit equals 100 centis of that base unit. Or if we were talking about grams, it would be 1 base unit equals 100 centis of that base unit. Okay, so that prefix piece can be put in front of any base unit. And in the case of centi, it means you always have 100 of that particular base unit. All right, so now the 3 relationships you have to know. You need to know that 1 base unit, and I'm going to use the base unit meter in this case, okay, but I'll underline the base unit so that you know that's the base unit. 1 base unit is equal to 1,000 millis, okay, that's your prefix in this case. I'll put a star there for prefix. And so in this case, because our base unit is meter, so 1 base unit equals 1,000 milli of your base unit. That meter could be changed to grams. It could be changed to liters. Okay, so it could have been 1 liter equals 1,000 milliliters. So that's one relationship you need to know. A milli is 1,000 of your base unit. The second one you need to know, again, using the base unit meter in this case, is that 100 centis are in 1 base unit. So 1 base unit equals 100 centis of that base unit. And here I showed you the 3 different possibilities there: meters, liters, or grams. Okay, so in that case, because milli and centi are smaller than the base units, where's my meters? hold on. Okay, so I use meters as a demonstration because most of you have seen a meter stick before. Okay, a meter stick has lots of little individual markings on it. It's broken up into 100 pieces, and those represent your centimeters. So there's 100 centimeters in here. And then it's broken down even further into millis. And it takes 1,000 of those millis to make this up. Okay, so those are smaller prefixes. So it has more of them in a meter. The last conversion is actually a bigger prefix, meaning it is larger than the meter itself. If we take 1,000 meters and we put them end to end, we get 1 kilo or kilometer. Okay, so in this case, our prefix tells us that there are 1,000 base units in our larger prefix this time. Okay, now that's kind of confusing, but here's the good news. Because all of our tests are open note and quizzes, I would strongly suggest you start taking the time to build like a little cheat sheet to have quickly available anytime you're doing work or quizzes. So the first thing I would put on my cheat sheet is these 3 conversions. And if you really need it written out, take the time to do for your second conversion, you can write all 3 of those. For your first one, you can write all 3 possibilities so that all you have to do is quickly look and find them, okay? Because remember that base unit can be changed out. I will not provide these for you on your quizzes and tests. Every other conversion we do that's not metric, like let's say we were going inches to feet or something like that, I'll provide all of that stuff. But metric conversions I will not give you. So you are responsible for those. Okay, whether you have them summarized or memorized, I don't care, but I won't give those to you. Okay, so now moving on to how we're going to use this information and other information moving forward. What do I need in my PowerPoint? Okay, so the beginning of this PowerPoint was just the stuff I gave you yesterday, but I do want to talk just a second about this slide. Okay, so here this shows you, I call them equivalencies. All an equivalence is it has an equal sign in the middle. Okay, so when you see an equal sign, we call that an equality or an equivalency because they're equal. And this top part where it says no naked numbers. What that means is because of what we're going to learn now and is going to apply for the rest of this year, every time you write a number, it's going to be important that you include the unit or label, sometimes you would call it, associated with it. So if we're talking about 100 centimeters, don't just write the number 100. You have to write the centimeters after it because those units are actually more important, if not as important as the number. Okay, so every time you write a number, it should have a unit or label associated with it if in fact it belonged with a unit. Okay, so never write a number without its unit or label. Okay, so in this chapter, the main goal is to teach you how to convert or change between units. So if I had 2 feet and I wanted to change that into inches, what is the process I would do to use that? We're going to teach you a process that will allow you to do very complex conversions. So it's going to seem a little ridiculous at first to change some of these simple things like 2 feet into inches. Mrs. Marquardt, I can do that one in my head. I know that 1 foot is 12 inches, so that means 2 feet is 24 inches, right? So why do I need to do something different than what I'm already doing? The answer is because I know moving forward that if you don't practice this with simple conversions, you won't be able to do it later. okay? And the process we're going to use is called dimensional analysis. It's a fancy name, but all it really is fraction math, okay? So because it's fraction math, we need to know what fractions we're going to deal with. And this is where those equalities came in that we just talked about for the metrics, but that you're also going to use for non-metric conversions. So what is a conversion or a conversion factor? A conversion factor is something that allows us to change to a different unit. So for example, change from meters to centimeters, change from grams to milligrams, okay? I gave you the example of 2 feet being changed into inches. Well, in order to make that conversion in your head, you still had to think of some kind of equality. You needed to know a relationship between feet and inches. And somewhere along the line, you learned that 1 foot has 12 inches in it. So you actually were working with an equality. You just didn't think of it that way. Okay, so we know that 1 foot equals 12 inches. Notice there's an equal sign in between those. You must know some kind of equality, some kind of a relationship that relates to units to be able to convert between them. Because we're going to do fraction math, we need to set up our equalities as fractions. And here's how it works with the conversion factor. Whenever you have 2 things on either side of an equal sign and we're doing a conversion, all you do is take one side of the equal sign and write it on top of the fraction line. Then you take the other side of the equal sign and write it on the bottom of the fraction. Okay, just trust me when I say that you can do this. I could explain the math behind it and how they're equal to each other and blah, 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 but it would probably just confuse you more. Just know that when you have 2 things that are equal, you can write them as a fraction. And because they are equal to each other, it doesn't matter which one goes on the top and which one goes on the bottom. So we could take the 1 foot and write it on the bottom if we wanted, and the 12 inches and write it on the top. Okay, so there's 2 possible fractions, which we call conversion factors because they're where the conversion is going to take place. It's going to allow us to change units. Okay, and we'll talk about the math behind that. What we're going to do now is I'm going to show you a set of videos that's going to kind of walk you through the whole process of what dimensional analysis looks like. Some of you are going to watch these videos and you're going to be like, oh, I get it. And like all of a sudden you get it. And this unit's going to seem very easy for you. For others of you, it's going to take some more practice, and we will be doing that practice, and we'll be walking through these together so that you can get this process. But it is very, very important that you dedicate the time needed to learn this, because if you don't learn it with these simple problems, it will be impossible later. Okay, before we even get into those videos though, we're going to review some fraction math just so you can be comfortable with the process. So let me pull again up my whiteboard. Okay, so I'm going to write a math problem using fractions here on my board. Now these are variable x's, so I'm going to make them look like this. Okay, if some of you maybe, because you don't see a lot of time signs anymore, it could also look like this. Okay, so what we're doing is we're taking 2 fractions, 3x over 1, x being a variable in this case, times the fraction 10 over 5x. equals. So we would want to solve this. So basically, we want to figure out what we do mathematically here and then simplify it. Does anyone want to try to walk us through this process? I need a brave soul, and it is absolutely fine if you make errors, because errors is a part of learning. Riley, thank you for volunteering. Just try to explain what you would do.
I would try cross multiplying it. Is that
okay? Number one answer given, and as a matter of fact, every class gave that answer, but I want to clarify something here, because you think fractions and you think cross multiply, but remember, cross multiplication only works when they're on opposite sides of the equal sign. So if this had been, then cross multiplication would have worked. We multiply, you would have had 15x squared equals 10, okay? But the equal sign is not in the middle. We have a times sign in the middle. So cross multiplication is not the way to do this. Let me rewrite this. Yeah, so let me just, I have it rewritten down here. What if I drew that fraction line the whole way across? Evan, explain what you would do. Okay, stop 1 second. So you take the two numbers on the top and you multiply them. So that multiplication sign applies to the top and the bottom. So this would be 3x times 10, which is 30x on top. I'm going to keep my fraction line, and then we would have 5x on the bottom. Does everyone see how we got there? Okay, now this is not simplified. You can't leave it like that because it can be reduced. So go ahead, Evan, tell me how we would reduce this. Okay, so tell me what you did first. Okay, so we took the two numbers, the number part of it, and we divided it. So we get 6 as our number. What about those x's? Because we have an x on the top and an x on the bottom. They cancel out. Remember, when you have a variable on the top and the bottom, they can cancel. So because we have an x here and an x here, they go away. X over x is 1. So the answer here is just 6. No x's left in the answer because they went away. We're not going to use variables in chemistry, okay? But we do have letters because we have units or labels like centimeters, meters. They're going to act the same way. If this had been centimeter instead of x, it still would have canceled out, okay? Because it would have been on the top and it would have been on the bottom. They're going to go away, okay? So units or labels work just like variables, and they're going to cancel, okay? So just recognize that when you're multiplying fractions, you multiply everything on the top and multiply everything on the bottom, and then you divide those two numbers. Okay. Now we're going to go to the videos. Okay, so the first video is going to show you this entire process of unit conversion using conversion factors using this fraction method, okay? So it's called dimensional analysis. Let me just double check and make sure I actually have sound turned on. I don't.
That helps you communicate clearly and effectively. It works as a simple browser extension and integrates with very popular apps such as Google Docs and Gmail.
In this video, we're going to look at how to convert units using conversion factors like this and canceling units. Some people call this dimensional analysis. Some people call it the factor label method, but you are going to call it easy by the end of this video because we are going to go step by step to show how to solve these kind of problems. So here is our first one. We want to know what is 3.45 pounds expressed in grams. So the conversion that we're going to be doing is we're going to be doing pounds to grams. And we're going to be starting with 3.45 pounds. Okay. The next thing that we got to do is we got to go and we got to find some kind of relationship between pounds and grams. So how many pounds are there in how many grams? You can find this information on the internet. You can find it in a textbook. You can probably find it like in the back of a notebook where they'll have a conversion table for the units. It's going to look something like this. We've got a bunch of these relationships between different units, and you want to find the equation that talks about pounds and grams. Okay, so it's going to be this one down here. 1 pound equals 453.6 grams. So this is the statement that you're going to want. You can get it from a variety of places, but it's important. Now it does.
Okay, just real quick. I will always provide you with conversions with the exception of those 3 metric ones. Okay, so anything that's not related to a metric prefix to its base unit, I will always provide it for you. You won't have to look it up. Okay, but those metric ones you need to have memorized or written somewhere.
It doesn't matter whether pounds or grams is first. It can be flipped just as long as it has both pounds and grams in it. So now we have this statement that tells us how pounds relate to grams. We're going to use this statement now to write 2 conversion factors. A conversion factor is expressed as a fraction with a top and a bottom. So here's how we can take this and write a conversion factor. We're going to take this side of the equation, 1 pound, and put it on the top of the fraction, and there's a fraction line, and then this part of the equation is going to be on the bottom. So it's going to be 453.6 grams. Now that's one of the 2 conversion factors. The other conversion factor that we're going to write is we just take this and we flip it. So this 453.6 grams, we put that now on the top of the fraction and divide it by 1 pound. So 2 conversion factors that you can write from this statement here. Either one of them is correct, but only one of them is what we want to be using here. Okay, so we're just going to use one of these. The one that I'm going to use is this one, because pounds is up here and pounds is down here. Let me tell you what that means. So 3.45 pounds, that's not part of a fraction, right? There's no fraction line here. And so if something does not have the bottom of a fraction, you just assume that it is the top of a fraction. It's the same as it being on the top of a fraction.
Okay, so if it bothers you that this is not a fraction, okay, because it's going to screw you up, just draw a line and write it over 1. Okay, you can turn that into a fraction by just drawing a line and writing it over the number 1. That's optional though, okay? You don't have to do that if you understand it without turning it into a fraction.
Fraction if it doesn't have a bottom. That's what I mean. Now, on the other hand, pounds is down here on the bottom of the fraction, okay? And when we're using conversion factors, we want to get rid of pounds and we want to be left with grams. And it turns out that if a unit is on the top on one side of the multiplication sign, and then it's on the bottom on the other side of the multiplication sign, it cancels out. So pounds is on top here, pounds is on bottom there, so they both cancel out, and that leaves me with units of grams. So just to review, I wanted to use this version of the conversion factor because pounds was on the bottom, and this way pounds will cancel out. Now, I've canceled out pounds. I'm ready to do the math. What's it going to be? I'm going to do 3.45 times 453.6 divided by 1. Or, if you have a fancy scientific calculator, you can plug this whole thing in one expression. You can do 3.45 times, and then write this conversion factor in parentheses. 453.6 divided by 1. Now, you don't really have to worry about the 1 too much if you don't want to. I'm just putting it there because sometimes this won't be a 1. So I just want you to get used to dividing by whatever is on the bottom of the fraction. even if it happens to be 1 in this case. So however you decide to plug this into your calculator, when you crank through it, you're going to get the same number, and that's going to be 1,560. What are the final units here? Well, I canceled out pounds, so the final units that I'm going to be left with are grams. I'm not worrying too much about significant figures when I'm doing these unit conversions, just for this lesson, because I don't want to add another thing in here to confuse you. There'll be a lesson later about how to do significant figures with unit cancellation, but I don't want you to worry about sig figs now. Just worry about figuring out how to do the unit conversions. So anyway,
Okay, we're gonna stop that video right there. Okay, some of you, like I said, boom, you've already got this. You're like, okay, I'm ready to go. Okay, just bear with me. We're gonna show you a couple more videos. What these videos are gonna introduce is another way of writing these. Okay, so if that fraction method to you is like, I get this, I'm gonna stick with this, you are absolutely welcome to do your problems this way. When you do them by hand, but the work I have set up for you in like Classkick and stuff is going to use this other symbolism, but it's going to show you just another way to set these up. The math is still the same. It's still fraction math. It's just we're using lines instead of like time signs, and it is called goal posting. Okay, it is still dimensional analysis. It's still unit conversion. It's just we're using something called goalposts to set up the problem. So these are just going to introduce you to that.
This topic is probably the most important topic to understand in order for you to successfully pass your chemistry class. You will be converting units all semester long. So let's start with understanding the idea of unit conversion and how conversion factors work. Let's say you wanted to translate a phrase from English to French, but you don't speak French, you only speak English, and you don't have access to Google Translate. You do, however, have a friend who speaks both English and Spanish, and your friend knows someone who speaks both Spanish and French. So if we wanted to go from English to French, your friend would translate the phrase from English to Spanish, and the person your friend knows would then translate the phrase from Spanish to French. Notice how the people who knew two languages were either in the middle or at the end of this, and the person who only knew one language was at the beginning. This is how unit conversion works. The given unit is what we start with, and your conversion factors are in the middle and at the end. A conversion factor has two different units. They allow us to go from one unit to a different unit. Notice that we always align the same units across from each other so they can cancel out, and thus allow us to change the unit. You know where a conversion factor goes based off of the previous unit. You will often see the setup of unit conversion questions like this, where the point where the lines meet represent multiplication. As you progress in this class, you will see questions like this or even longer setups. Again, this just means there are multiplication symbols here. The metric system and dimensional analysis are two topics where unit conversion is used. Both topics allow us to convert units.
We're going to skip that because we already talked about the qualities associated with the metric system, and they're just going to fit in the same way any of our other conversions will. Okay, this last one then now does a math problem using that series of lines that we call goalposts.
RobinReaction.com. In this video, I'm going to explain how to do dimensional analysis, which is just converting units from one to another. So it's the same thing as unit conversions. It's also called the factor label method or the unit factor method. No matter what you call it, it's just converting from one unit to another. In this video, I'm going to go into a good amount of detail with how to do these math steps, but if I'm skipping too many steps and you still find yourself confused, I have a video on unit conversion, which goes over every single possible step pretty slowly so you can completely get it. So I'll link to that video. So if you watch this video and I'm going a little bit too fast for you, go ahead and watch that video and then come back here. So first, let's go ahead and do this first problem. So we're going to convert 3.2 miles into feet. All right, so the first thing we're going to do for these problems is we're going to have this grid system. That's usually how dimensional analysis is shown. Sometimes it's just going to be parentheses. Sometimes it might look a little bit different. But in general, we're going to set up something that looks like this. We can plug our numbers into it. And all it means is that we are going to be multiplying or dividing these numbers. It's just a way that we're going to do our algebra or our multiplication. So even though it's a grid, what it really is doing is it's multiplying. We go ahead and we put 3.2 miles on the top. We always put whatever number we're given, in this case 3.2 miles, on the top. And I like to have a 1 on the denominator just to remind myself I'm really just doing fraction math here, even though I'm drawing it like a grid. So next, we have to go ahead and get our conversion factor. So that is down here at the bottom in the box. So a conversion factor just tells you how many units equals how many of your other units. We're always going to have at least 2 units in these problems. And it's going to depend on your class if you have to memorize them or not. I'd say it's about 50-50 between teachers that make you memorize conversion factors or teachers that give them to you. So please feel comfortable asking your teacher, hey, are you going to give them to us, or do we have to memorize them? And if so, which ones do we have to memorize? That's something that they just really need to tell you. So we can see in this problem, our 2 units are miles and feet. So we go ahead and we can find that we have this conversion factor right here that's going to relate miles to feet. And our next goal is we want to cancel out miles, because the goal is to cancel out miles and end up in feet. So to do that, we're going to just write miles on the denominator, because writing it down here is going to allow us to cancel out the miles that's on top. That's just how we cancel in algebra. We have 1 on the top, 1 on the bottom. It's all being multiplied and divided. We can cancel. Next, we're going to add our other unit, which is feet, in just the spot that remains. In this case, it was on top, so we can just add it to the top. And now we plug in the numbers that are associated with each unit. So we can see that next to mile, we have the number 1, so that gets written in next to mile. And then for feet, we have 5,280, and that's going to get written in next to feet. Now that we have our number that we were given in the problem and our conversion factor all correctly plugged in to our dimensional analysis, we can go ahead and cancel out miles, and then we'll end up in feet. So now the only thing left to do is to go ahead and do your math. So both 3.2 and 5,280 are on the same side. They're both on the top, which means they get multiplied together. The denominator is only 1, so we can ignore it or divide by 1, same thing. And we get 16,896 feet. So now going ahead and doing sig figs, and only worry about this if your teacher has said that you need to do problems using significant figures, otherwise you can ignore this part. We can go ahead and see that 3.2 has 2 sig figs. So that's how many our answer is allowed to keep, which means that we're going to round up to 17,000, and our final answer is going to be 17,000 feet.
Okay, we'll talk a little bit more about the sig figs. We will